Hello everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We have to go put PNG reading integrated into our game. We already wrote the reader, and now our goal is to sort of retrofit that into our existing asset system, which loads out of our own file format. And so what we want to do now is support the ability to take PNG files that an artist drops into, say, a directory somewhere, and import them into our data files so that we know that they've been processed and can now be used as regular game assets in the course of running the game, as normal. So that's our goal. Let's see. Last week, we made an extension to our platform layer to support our ability to watch files. And this is important because what we would like to do eventually is make it so that the artist can just save a new PNG over an old PNG and it'll just magically appear in the game, because that's generally what you expect from like a hot loading system. It's exactly analogous to how we do our code, right? The way we do our code currently is when you compile the code, the game looks and sees if the game DLL has changed, and if it has, it just loads it in and runs with that instead of the old one. And that's exactly what we want to do with our PNGs now. We want to make it so that if it sees that there's a change, we load it. But obviously, we don't want to load every PNG every time to see if there's a change, because that's going to be too slow. So what we did instead is made it so that we can actually see what the date stamps are on the PNG files themselves. And then if we see one of those date stamps change, we then know that we should look at that PNG to see whether the contents of it have also changed. We don't know when the date changes that the PNG has actually changed in any meaningful way, right? You can you could open up a PNG and resave it over itself, but not actually change the data. So we do want to actually compare the data when we load it in. We probably want to look to see if it's actually changed, because if it hasn't changed, then we don't actually need to update the art pack file at all. But we do need to at least look at it once the date changes, because it means that the contents may have changed. So the way to think about the date is that the date is something that is sort of a marker that just says, could the contents have changed? And then once we see that marker, we then know, okay, we have to go do further investigation. But it's not actually telling us that the file changed. It's just telling us it might have changed. So that's what we're going to look at now. Let's go ahead and get started on that. So if I load up our current state of affairs here, what we did, should load the project file. What we did with our PNG reader is we, first of all, extracted the PNG reader into a usable chunk here. So now we've got sort of this bit right here where you can call parse PNG, pass it to memory arena, and you get back the image. So we did a good job like pulling that out. That's all ready to go. So now what we're just looking for is when do we actually call it and how do we use that feature now that we have it. And the answer to that is, okay, inside our asset system, as you may recall, we sort of have this notion that we, at startup, look through the assets that we have. You can see here we loop over them and we create sort of a indexing of what the tags are for each of our assets and that sort of thing. And that is immutable. It doesn't change for the entirety of the run of the program. And that's the part that we need to expand now, because when we look in here, right, we've got this game assets. You can see we have some set of loaded files, we have some set of loaded tags, and some set of loaded assets. And what those are is they're basically arrays we use to look up into when the game asks for a particular thing. It jumps in there to use it. Now, we have two distinct jobs now that we want to tackle to modify what we're looking at here. And the reason that we want to modify what we're looking at here is because in addition to now sort of having an artist who can work on the project directly, we also are in a situation where we know more specifically what that artist is producing. So, let me go in the art directory here. So if you look, for example, at some of the test art that we have here that is, you know, indicative of what we might see in the game, you can see that there's various structural concerns. So we have a type of image that's just what a block looks like, right? And you can see that like a block has different components. There's like different sidedness to blocks and stuff like that. And so, you know, then we look at something like a character, and a character has like a head and a body, right? And stuff like this, and different facing directions. And that's what's going to get added into the game now, right? So we kind of know exactly what's being put in there. Now, we have two ways we can go about tackling this particular problem. One is that we can just translate those into tags, right? Which is maybe what we should do. The other is now we can also take this opportunity to refine our tag system to more closely approximate what it is we're actually doing now. Because, you know, we now know a lot more, because once an artist is making art assets for something, we now know a lot more about what's going on, right? So we have, we can sort of look a little bit to, we can, I'm not sure how to say this, we can envision making changes to how the assets are stored in something that makes it more specific now and more efficient. With the tag system, it's very generic. You can do whatever you want with it, but it's more expensive, right? You have to do matching on values, and it creates sort of a more extensive process for the game to figure out what asset you're actually talking about. And so we have to kind of make a decision at some point whether we really care about that anymore. If we have a set of art assets and we now are going to just lock it down and say this is how assets will come into the game, then we really don't have to worry anymore very much about those assets being tagged in arbitrary ways. We can simplify that system to a more direct indexing that wouldn't require us to have tag matching per se, right? So I really don't know what we want to do about that, but it's kind of a good idea to keep that in the back of our heads now, because we definitely have the opportunity to change how that works. So that's what I would say. All right. So let's move forward here. So if we take a look at the assets that we're actually storing right now, an asset is defined right here. It has a state, and that state has to do with whether or not it's like what we've done with it, right? So, oops. So if we take a look at the asset state here, we can have something that's unloaded, something that is trying to be loaded, and something that is loaded, right? And what that does is it basically allows us to determine whether we need to load it from disk or not when it gets used, right? Because if it's going to be used, we need it to be in a loaded state. If it's not in a loaded state, we need to do something about it. If it's queued, we can just wait because it will get loaded. If it's not loaded yet, we need to queue it. So that's our, that's the way the state works. We then have a memory header. The memory header, I think, probably can go away now. And the reason that I think the memory header can probably go away now is because all of our stuff is going to be the same size now. One of the nice things that we did with, now that we moved to OpenGL, is we can just introduce a constant size for asset stuff. We can just, I had Anna put them into fixed size boxes so that we can do more reliable memory allocation on them and stuff like that. So I think we can probably get rid of this asset memory header idea in the future. I mean, not get rid of the information in here, like the total size and stuff, probably. Well, we might be able to get rid of that as well. But I'm just talking about the fact that we had to look at memory to reuse it in a non-direct free list kind of way. That stuff we can probably simplify quite considerably now if we would like. So that's nice. So anyway, inside here we've got this this asset. It's got a pointer to the memory header there, and then it's got the actual asset in question, which is this information here, and a file index as to which file that came out of, right? So if it needs to get reloaded, that's where that would come from. So what we need to do now is start thinking about how this is going to have to change. So you can see here we've got first tag index and one past last tag index, right? We really, in our first attempt, we really can, if we want to, just not touch the tag system at all. And the reason for that is even though this seems like a tightly packed system, it's indirectly offset. So what you can see here is these are indexes, not pointers, which means that if we wanted to, when we look at this tag array here, and we've got a tag count and a tag array, what we can do is at startup, allocate vastly more tags than we actually need, and just leave headroom there to put more tags in. So then every time we load an asset, we just blast tags in there, right? And so that's a pretty straightforward way of making the system expandable that actually doesn't really cost us anything. And I know that that sounds a little bit cheesy at first because you may be thinking, well, if you were to do that, what happens if the artist is just running the game for a really long time and eventually they reload the art enough times to hit the top of the tag count? Well, guess what? No one cares. Why? Because the game assets could just be restarted, right? Remember, we have a way already of just reinitializing the art asset system. At startup, it just looks through the files and loads the indexes out of the files, right? That's all it would have to do. We could just do that again, and then we have a nice, tightly compacted tag set that just is exactly the right number of tags without having all that dead zone in there, right? So I think our main problem that we're going to have is not with that, right? It wouldn't be with dealing with in-memory tag stuff. I think the problem that we're more going to have is the fact that when we replace a particular set of assets that already exist, we need to reuse the tags from that asset or remember that we've freed it to put other tags in there eventually for the permanently stored file. So it's really updating the permanently stored file that's the hard part, because that's the thing that has to have the data actually correct. Now, and that's also, like I was saying, why I think it might be nice if we had a different way of indexing things. Since we know that we don't really need the tag stuff now, I don't think, based on just the kind of art assets that we have and will have, it doesn't look like it's super necessary. So that's the reason I say we may want to move away from that going forwards, just because it doesn't seem like something that's really necessary, and it will create headaches for us for management. I mean, you could just never deal with it and let the tag array just get massive, but that just, that doesn't seem very efficient, and you're just bloating things out for no reason, when I think we could probably do something better. And the thing that we would probably do better here, right, is, again, it depends really on how we're going to use these. I had originally envisioned a system that maybe was a little bit more arbitrary with how things were loaded. But looking at how we ended up kind of going with it, just in terms of how the art wanted to be made, it seems like it kind of wants to be, I don't know. I think that we may want to rethink the tagging from a standpoint of, rather than having a collection of tags in that sense, you may just want to have more of a fixed set of tags that aren't arbitrary. And yeah, I really just don't know. So when you're picking something like a hat, there's just 2 parameters or 3 parameters or something that define hat. I don't know, and you pick them. I'm not sure. Again, like I said, it's really kind of confusing to me how this is actually going to shake out. And so we may have to get a little further down the road till we really know. But yeah. But anyway, that's the situation, and we'll have to think about it a little more. So anyway, that's the only part that I think is going to be particularly problematic for us there, where we're going to have to start thinking about things a little bit more carefully. So yeah, we've got like we've got these types here, and these will now start to reflect what we actually have in the art itself. Yeah. Anyway, so thinking about those tags is sort of something, I guess my brain keeps kind of going there, and I don't know that I really want to do that yet. But anyway, now that I've got that all out in the open and you can think about it too, I'm going to go ahead and do the stuff we actually know how to do, and then we'll come back to how we want to do the tags, which I don't think we know how to do yet, because, I mean, obviously we know how to do any particular implementation of it we want. It's not hard. The question is, what is the correct design for that makes us have the minimal amount of frustration for what we actually want the game to query. And it may be that we just need to wait a little longer and start doing stuff like putting some of those little orphans in the game, in having you be able to wear different hats and stuff. And then when we see what the code looks like that does that in the entity system, we can have a better understanding of how we actually want to query these things that will be the least amount of frustration for both sides of the system, right? We want the entity system to have an easy time saying what it's trying to do, and then we also want the asset system to have an easy time managing it. So we'll look at it. All that being said, let's go ahead and look at what we actually want to do here. So what we've got, excuse me, is the ability to loop over these files. We have the ability to loop over these files, and we have the ability to see what's changed, but one of the things we're going to have to do is keep a record of what those were. So at the very least, I know I'm going to have to do something like this, where I have a file that I know that I'm watching, and I know that I've got some date that's involved that I can look at. So if I go here to the platform layer, if you remember, we sort of made this platform file info here. We had this file date. So I know that there is a file date involved, right? And furthermore, I know that there was a file name, right? So there was some kind of a name that I was looking at there that I need to like be aware of, right? So I've got something like this, where we've got a name that says what the file is, and we've got a date that says what we think the last time the file in question, you know, when we think that actually was last changed. And so then what we want to do is we want to be able to do something where we kind of check these things periodically for updates, right? So when we have one of these watch files and got a base name and a file date, I can use something like this to check, to trigger it. Now, I'm going to want to look it up on the base name because that's what's going to be coming back, and I want to match that out. So I'm probably going to want something like this. Where I just have a hash of the names, and I can look them up in there via some kind of a string hash, right? So I can look these up. I can get information about them as I go. So when I have this information and I do the watched file stuff, what I want to be able to do after that process is I want to be able to reload a file if it's changed. So the additional thing that this watched file would have to have is it has to have some knowledge of what assets came from this watched file, right? So inside here, we've got some number of assets. Those assets correspond to what was in the file. So for example, if we look at one of these files here, you know what, I should load one of these templates like this. So when we load up a PNG, we've got something that looks like this, and each of these squares is a different art asset, right? So for example, up in here, we have the rightward facing default body, leftward facing default body, and so on, right? I'm sorry, dodging leftward facing default body, right? Blah, blah, blah. And then if you take a look at the actual monsters and stuff that are in here, or whatever, you know, the whatever are the various like things are that you've got to go into that slot, right? Here's one that's a mummy. Again, we have to look at these in something that actually knows how to look at transparency. What the heck is this? All right, I've never seen this program before. But anyway, at least it handled the transparency properly. All right. I don't know who makes an art package that actually has stuff that isn't in the art sort of like showing up. Yeah, all right. Microsoft is the answer. So looking at this in here, you can see like we've got the different bodies of this thing, but a bunch of them are left empty. This is by design. So when we look at one of these things, we don't want, let me get that template back. When we look at one of these things, we don't want the artist to have to do any more work than necessary for a particular character. So a lot of times characters might just have, say, this part here. In fact, sometimes if the character, for example, doesn't have a head that really turns, there might only just be one, right? Like maybe there's only this one. So it might have all the bodies, but just that one. Or maybe just this and this. There might be only two in there. So every one of these squares is a potential asset, but only, maybe even just two or one of those squares is actually required to make a usable monster or something like that, potentially, right? Because some monsters may be very simple, while others might have more stuff in them, right? So what we want to do here is we want to we want to put these things in categorically so that we extract the squares, put them into assets, and we want to remember for any given one of these files, we want to remember where we put everything, right? That's kind of crucial. So what I want to do here is I want to say, all right, we know there's effectively a maximum because those tiles there, it's like an 8x8 grid, right? The maximum thing is an 8x8 grid of things. So there's no more than 64 actual assets that could have come out of here. So there's sort of an asset count, if you will, but I'm not going to even have an asset count. I'm just going to say like asset indices, and I'm going to say there's 64 of them, right? We could even say 8x8 if we wanted to be a little bit more specific about what we were doing here. And note which one it is, right? So it's like X and then Y, or let's do Y then X because that's how we would do it if it was pixels, right? And what I want to do here is when we load in one of those files and I look through all of the squares, what I'm going to do is every time there's an asset in one of them, I'm going to record that. So this will be all zeros initially. And every time I see one and record that, I'm going to say what asset then takes that place, right? And fortunately for me, I think, and I'm just guessing here, but I think our tag problem is kind of not that big of a deal here because if you think about what's going to happen, anytime you look at an asset, the tags that go with that asset are the same no matter what square they're in a sense, right? I said that exactly backwards. The tags that go with an asset are the same for that square no matter what the asset is. That's what I was trying to say and failing to say, unfortunately. So if you, if you think about what that means, when you look at one of these, this asset here that's from this square, if I replace this asset with a different image, the tags don't change. The tags are the same, so I can literally replace the asset and just refer to the same set of tags I originally added, which stops the tag bloat from happening pretty conveniently, right? So that's something good to, that's something pretty good to keep in mind, right? Again, I'm not sure we really want to have the tags go down that far because we know that this is a fixed layout, so in the future we probably just want to use a fixed layout for it. And we'll have to think about how we want to do that going forward. But yeah, there you go. Okay, so I think this would tell us what we need to know. So we could look at a watched file. We could say, okay, if it changed, these are the assets that need to be replaced. We loop through all of the new file. Any time we see an asset, we will put that asset into place and replace the old asset's information with it. And we can probably reuse the same asset as well. So that's probably easy to do. I don't know. We'll see. But when we take a look at the asset itself, let me take a look at where that is here. This is the wrong file. We take a look at the asset itself. In the case of bitmap, which is the thing that we're working with here, when we look at the way this is stored, it looks like we just have a header that's the dimension and the line percentage, and then we have the pixels that come after it. So what we would need to do there for the HHA bitmap, just thinking it through, is when we look at the asset, it's going to have this stuff here. No, it doesn't. Never mind. Data offset tells where it goes. Yeah. So it looks like the main problem we would get there is that the data offset would have to potentially be changed. But again, the nice thing here is if all of our assets are the same size and we store them uncompressed, at least during development, like we could try to do compression on them later when it comes time to ship. But when we're just during development, we can leave them uncompressed if we want to. If we leave them uncompressed, that means that any asset that replaces another asset came from the same location in the bitmap file, which means it's still the same dimensions, which means that the data offset already points to exactly enough space to hold it, so we shouldn't actually have to do any reallocation. You know what I'm saying? So I think this part of the process is actually going to be pretty straightforward. I think reorganizing the tags is going to be the hard part here because we need to because it's something we need to think up hard about and experiment with. But I think the asset part is actually pretty straightforward. All right. So I'm just going to make a standard hash setup here. Exactly what we've done it many times before. So what we'll do is we'll just look in the hash file. We'll see when we get something that has changed, we'll just go in there, we'll modify it. This HHA asset is just inside the asset system here, right, where we have that asset listed. The only thing that I think we're going to have to be aware of is when we look at this HHA asset here, this may need to be a more extended piece of information. So this HHA asset is telling us where to put the replacement data, but that data that we're overwriting, I'm not explaining myself well. An HHA asset comes potentially originally from a data file that we don't know how it got there, right? When we boot up the game, our HHA assets that we have right now, for example, that did not come from the hot loading system in any way, those assets, we don't know anything about them, right? This assets pointer here is just a big list of these things. Where was that? Right here, right? So we don't know where it came from. We copy this information out of the file, and then we don't have it, we don't know where it came from. So when we go to replace one of those assets, we're in trouble because we don't know where to overwrite the file to tell us. So in a sense, we actually need to store an additional piece of information here that tells us how to overwrite this particular asset. Now, what I'm going to propose is that since all of our assets going forwards go through the watched file system, I think maybe that's the right way to do that, because we know that we're never going to replace an old asset with a new asset in this way. that what wasn't through the watched file system, because all of our old assets are the wrong dimensions anyway. So we can't reuse an old asset header anyway. So we could do it through here. The only thing that I think maybe trips us up there is that we still need to go back and nerf the old asset so that it doesn't participate in matching if we want to overwrite it. So that part, yeah, that part seems like something that we just have to deal with. So I guess I will just put it here. So every time an asset gets loaded, I'm just going to remember where it came from. I'm just going to say that that's something that it has to record. And I think, like I said, I think this part can get simplified in the future. So basically what I would propose is eventually we probably want to just move to a fixed size system where we just have like a couple different buffer types. And the reason for that is we want to kind of use the texture memory this way and move things into the texture system in a way that doesn't require redraw restarts all the time and stuff like that. So I feel like we kind of want to play with that a little bit. And I think we're going to get to a point where we can sort of collapse this stuff down in a nice way. We're not there yet, but we're going to want to. I'm going to leave that alone for now and just work with the asset reload for right now, because that needs to get into place either way. So this is like asset index in file. That just tells us for this file, here's which one of the assets we need to overwrite in that case. I'm also going to make a note here. That we're talking about this right here, this assets array, because asset index now as a phrase is ambiguous. Do I mean the asset index in the file that it came from, or do I mean the asset index in the global assets array, which has had all of those merged together, right? Because those are two different things. And in this case, I'm talking about the global one, right? Okay. So let's do the watched fileness right now. And what I'm going to do is I'm going to make it so that at first, what we'll do is if you hit a key, it'll do the reload. So basically, like, you can save as much as you want, and then you hit a key, and it'll do the reload. Eventually, what I'd like to do is probably just put it on a background task so that it'll just automatically reload, right? One of the nice things about dev machines nowadays is we've gotten back to the point where a consumer machine is underpowered compared to a developer's machine, usually, right? So typically, for example, an end user's machine, you're not going to be counting on having 24 cores or something. But a dev machine, you can. You can buy a 24-core dev machine or something ridiculous like this if you really want to. In theory, right, isn't there some nutso Threadripper thing coming too? Like, so 32 cores in a Threadripper 2, right? So eventually, what we will definitely see is, if not today, at least a little bit down the road, but I would argue today, any artist machine can trivially be made to have a ton of cores, right? So you can afford to have a background core doing nothing but reloading artwork 24/7 if that's what you want, and it will not really materially affect the performance of the game, because even if your game scales perfectly and scales to all 64 threads on a Threadripper 2, causing one of those threads to have to sit around reloading artwork is only going to slow your game down by 1/64th of its speed, right? Now, that's not entirely true because loading artwork involves the disk and right, blah, blah, blah. Like, who knows how it might affect it a little bit, but we're splitting hairs. The machine power is such that if you would like to, you can easily just say on a developer's machine, we have something in the background sitting around that does nothing but developer work. And it won't really make it so that the artist can't play the game as intended. It should be fine, right? That was not the case, maybe 10 years ago, right? But it is now. So anyway, so we have one of these watched files, and what I want to do is make it so that maybe you hit a key, and then we reload some stuff. So what I'm going to do here is I'm going to make a little thing that's like check for art changes or something. I don't know. I'm just making up this name. And what I want to do is pass it the game asset structure. And what it's going to do is it's going to petition the file system again and say, hey, operating system layer, can you tell me what all the files are that are in the art directory? I might want to reload some of them, right? And we've already got we're already sort of doing one of those in here already. This file loading part here, you can see. This was Snuffleupagus-oriented programming, by the way. So what I want to do is I want to, load that in. I want to ask the platform to get me all of the type files that are PNGs, I believe. Yeah. And so I want to say, how many PNGs are there? I want to go ahead and loop through each of those, like so. And then every time we get one of those out, it's going to have a base name. What I want to do is I want to create a standing structure that will never go away. It's just a permanent record of the fact that this file existed, right? What I want to do is I want to create a permanent record of the file. So what its name was, what its date was, and what assets it used, right? So I want to make this, and then I want to see for any one that I have that appears to have changed. I want to actually ask the PNG loader to load it, and then I want to loop through each of the chunks in the file, looking to see what information there is about, like I want to see what, how should I say this? I want to see what assets actually exist in the grid and whether or not those assets are different from ones that I have already in my permanent storage. Now, one of the things that I probably should do is, instead of calling this a watched file, I might call this something slightly different. I might call this a source file. And the reason I'm going to call it that is because I want to think of this as something that probably has a broader scope than just watching the file. So, for example, we may want a bunch of information, like tweaks and stuff, to apply to the things in this file. You remember us mentioning, maybe it was last weekend, I think, when we were sort of doing some preliminary work here, there's information that may need to be added that is additional on this file. So, if we look at this, for example, I really need something that's going to... I don't know what these things are. What's Paint 3D? Oh, that's this thing. All right. So, strictly out of curiosity, what is 3D about this? Like, what happens in 3D here? Does anyone know? Like, how do I make this 3D exactly? Okay. Okay. So, what? Why was it only painting on the plane? Is it? Can I paint on this block? So they're just trolling at this point. Are they just trolling me at this point? They made a 3D paint program that can't paint in 3D. Am I missing? Is that actually what I'm looking at right now, or is that do I just not know how to use the program? I mean, if it's 3D paint, I should be able to paint on the cube, right? I mean, that's like the minimum that would be necessary to make this a 3D paint program. Am I way off in left field here, folks? Please tell me if I'm being unreasonable. But it kind of feels to me like to call something Paint 3D, you have to be able to paint outside of the plane. But maybe I'm missing something. Like, is there a way to get some other plane so I can have like two planes or something? Oh, I can have a little sticky star, can I? Okay. So I can stamp things onto it? But I just can't draw onto it? It's fine. I don't know why even bother. All right, so let's just go back to something. I don't know. What about this? Is this a normal? Can't read that file? Okay. You know what? Developer Studio can read these. Although it may roll over and die if it tries to read a file that big. I'll load it with GIMP. I tell you, Windows 10 never stops trolling me. It reboots whenever it wants, and it installs a program called Paint 3D that can't paint in 3 dimensions. That's a new one. I guess that's kind of the same as calling Windows 10 Professional Windows 10 Professional when it is like one of the most unprofessional things I've ever seen. Okay, so here is all right, so here is an example of one of our files, right? What I was trying to say before I was interrupted by that sort of like that Microsoft troll is we may need to annotate this with additional information. So for example, if I wanted to say like this is the ground point, like this is where this thing sits on a hard point. So like, you know, if this is where it's supposed to be hopping to or whatever, that it hops to right, you know, that's the alignment of that thing versus a ground point. Or similarly, if I wanted to say, here's the neck, like that's where the head attaches to there, or you know. So if we want to annotate these with particular pieces of information, that information really isn't super plausible to edit in PNGs. Now, it's not that you can't. So PNGs, as we saw, can have information embedded in them. So, you know, for example, if Photoshop were a nice, easy to use program that artists had fun with, it would have things like alignment point as an easy thing to do. And then it could store that into, when it exported a PNG, it could store that into the text fields or something, right? But even though Photoshop does sort of have some features like that that you can kind of co-opt for this purpose, they're not easy for artists to use, and artists don't know how to use them. They're not intuitive, and they don't really do that sort of stuff very well. And so you typically don't find artists who would know how to do that necessarily. You can force them to learn, but usually it's better not to make an artist's life miserable and make them use problematic pieces of a tool if you don't have to. So an easier thing to do, because of Photoshop's sort of lack of really targeting the game industry as a thing, what we would want to do is add our own ability to specify this markup. But then that means, where does it go? It won't go back into the Photoshop files that the artist was using to make it. So the onus becomes on us to store that information somewhere meaningful, right? And so what we need to do is we need to keep this information around. So what I'd like to do is say that we probably want something like this. Right? And so this way, in addition to storing where I put everything, I can also store some additional information that means something to me. Now, when I look back and go, what's the actual data that we're using here? That should hopefully give me some information. So we see in here for the HHA bitmap, which is the thing that we're talking about now, we've got these two things, the dimension, the align percentage, right? So what I could do is just store this exactly this way, right? I could store the align percentage in here. And that's like the marked up alignment percentage. I suppose maybe what I could do as well is just say, look, maybe this is it. This doesn't actually need to be done this way. Maybe I could say, hey, look, that's just stored in the file. So the HHA bitmap tells us that information. How do I feel about that? I guess that's fine. So I guess maybe this was not really that necessary. Because what we can do is we can just go back in there and get it, right? We can just go back in there and look up what the align percentage was, because anything that we needed to mark up gets stored in the file by default. So it's really this thing that we would have to change. Seems reasonable to me. And that's really the only thing that we've got. We don't really mark up anything else, I don't think. Yeah, so I think that should probably be fine. I think that should probably be fine. All right, so anyway, looking through here, we've got the asset indices and the file date, base name, and the hash. That should be sufficient for doing what we want to do. So when we do our check for our changes and we come through here, we're going to do our platform get all files of type begin, get all files of type end. I think we passed this back in, right? So here's our actual change check. When we come through here to look up something for the base name, we're going to want to hash this string. I believe we already have a string hash. If we look here. Yeah. I don't know if we actually have any string hashes besides that custom one. I know I can search for better hash function and see it, but it looks like it's only in the... Yeah, so I guess we never really had one. Yeah. So I guess I will add one here that's just a way to do a generic string hash in here that's used the same way. Because it doesn't look like we've ever done any string hashing that wasn't custom, that wasn't specific to some part of the system, like the debug system that was trying to loop through and do other things at the same time. That's a pointer hash. Looks like this is the only string hash we have, and it's doing other stuff at the same time, which we don't really want to do in this case. What we could do is sort of localize this hash function a little bit here, which is to say that the update mode of this is something we could break out. So we could make a thing here that was like inline void update string hash that, you know, that I think just works. So we could do something like this, where you could do this update step, and that way everyone just uses it so that if we do make a better hash function someday, everyone would get it. So that seems kind of nice. Right? And then this sort of thing just does update string hash. And off you go. So that seems kind of nice to me, because it occurred to me as I was doing that actually this is going to be the same sort of thing. So where we actually go through here, we probably do want to do two different operations. One of which is we're going to actually produce the string hash that we would need to look it up quickly. But the other one is we're going to want to look at the file name to figure out what it is that we're looking at. Because that's the only information that we actually have to figure out what this should be. Block underscore, character underscore, cover underscore, hand underscore, item underscore, obstacles underscore, or none of the above. So for example, the title screen is kind of just its own thing here. All of those different pieces of information are going to have to be parceled out, because that's the only way we really know what we're looking at here. And so we kind of need some scanning that's kind of in line with this. So we are going to do an update string hash here, but while we're doing it, we're probably going to look for some other things. That's just how it's going to go, right? Okay. So coming through here, let's take a little bit more of a let's take a little bit more of a excursion in here. So looking at the platform information that we get, I think it's just the date and the base name that we actually need. I don't think we need anything else, right? Well, I mean, the size we would use once we actually go to read it, I suppose, but that's about it, actually. So what we want to do here is we're going to have to take the base name. Let's actually scan over that. So we'll look until we get to the null terminator on that. So looking over the base name, that will allow us to bring up our hash value. We're going to want some extra information here as well. And I think one of the things that we probably want, and I talked about this before, is that I think we're going to want to start actually having a real string here. The reason for that, again, is just because, excuse me, once you start plucking pieces out of things, you tend to want to just have like non-null terminated strings. Null terminated strings are not good. I wish they had not been the standard in C. They're not a good way of storing strings. Strings should be stored as a length plus the pointer to the actual value. The reason for this is because once you do any non-trivial operations with strings whatsoever, you typically want to start talking about sub-regions of the string, and null termination does not allow you to do that. Null termination, just to give you a little bit of a background here of what I'm talking about, let me go ahead and move this out of the way. So null termination So what are the advantages of null termination versus length plus of null termination versus length pointer, and what are the advantages of length pointer versus null termination? Like what's better and how does it work? So the C style is null termination, right? It says that you have an 8-byte pointer, right, that points to just some series of characters, and we know that the last one is, 1 byte of zeros. So what that means is it takes, I guess you might say, 10 bytes to store the most minimal string, right? Because the minimal string would be 1 character long. We won't really talk about the null string because the null string in C style is difficult to define. You could argue that the null string takes 8 bytes to store or 9 bytes to store, depending on whether you're talking about a valid string that has nothing in it or a 0 pointer, which maybe you consider valid or not. So there's actually multiple states there with C style. It's worth noting. So ignoring that for 1 second, the minimal string, let's say, of 1 character is 10 bytes long, and generally speaking, right, the overhead is 9 bytes. So it's 9 bytes plus the character count for the string, right? So for length plus pointer, it's usually going to be, depending on how big you want your string maximum to be, you could say that you only have a 16-bit count and a pointer, but typically you use more of a 4-byte count and a pointer because why not allow gigantic strings, right? Because remember, the C style you could have pointed to something that happened to be 4 gigabytes long and it would be just fine. The C style doesn't care how long it is. So in order to be able to store very large strings, you would want at least a 4-byte count, and then you have an 8-byte pointer, which means that you actually have a 12-byte overhead, right? So it's 3 more bytes of overhead than the other one did. And if you really wanted the same flexibility as the C style, you would technically need 8 bytes on a 64-bit machine. Now, to be fair, it would never really be that many. It would be more like 6 bytes because there is no machine that can actually have 64 bits of actual memory in it. So you're never really going to have that. So it's more like maybe 14 bytes versus 9 bytes, but whatever. Either way, what I would like to make very clear here is you're dealing with just a few bytes of difference between the two. So there's very little overhead in either case that you really care about. You're pretty good to go in either one. And if you really cared about overhead all that much, you would probably have to do something different altogether anyway that was more about storing the thing inside the space itself or other kind of bit encoding and all these other sorts of things. So ignoring that, assuming you're just doing the generic version, you don't suffer that much more overhead in terms of actual memory you're going to care about, like with the count string, because you just don't typically have this many of these anyway. So the reason that I don't like the null termination is pretty simple. Usually you have things like, character underscore orphan underscore o2 dot png, right? And so this, for example, is a string. It's the file name, let's say. I want to parse this file name. So what I typically want to produce are things like this. String type equals character, right? String name equals orphan. My handwriting's really bad today. Even worse than normal. String number equals O2, right? String extension equals PNG, right? So typically what we want to do is like parse these things out so they look like this. Now, the nonsense way to do this is to actually allocate strings all the time. So you actually go through and you parse this out, you allocate a new string, you copy it into here, and it's just a disaster, right? tons of allocations, tons of memory copies, blah, 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 blah. But there's really not much other way to do it if you're going to use the null terminator version, because the null terminator version, the only way it could do it without allocation would be to overwrite the string. So you'd have to actually insert null terminators into these locations in order to point directly into the original string at these to give you these results, right? And once you do that, you can't use the original string anymore, because now the original string, character orphan02.png, has been corrupted. So you couldn't then go use it to say, load the file off disk by saying, here's the file I wanted to load, because now it just points to something that just says character. And then there's a null terminator, right? However, if you use length strings, all of this stuff becomes trivial. This is just a block of memory. It has the original stuff in it. These now just become length strings that point to here and have the length. Point to here has the length, point to here has the length, point to here has the length, right? So length strings allow you to break up blocks of memory into regions extremely trivially, and then you don't have any of these problems. So what I would like to say is that if you are programming in C and you're using the built-in kind of functions that they use, then you end up with a null terminator system like we have on Handmade Hero, because we haven't really cared much. We don't do a lot of operations with strings. But once you start doing a lot of operations on strings, like we're sort of starting to do now, we're going to parse this file name into pieces and do stuff with it. Having a length string becomes very important, because length strings are way, 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 way better than null terminator strings for just about everything you might want to do. The only thing that gets a little bit harder is you have to actually check against the count when you're processing them, and occasionally that's a little bit harder. Like sometimes when you're just ingesting characters, just checking for null is easier. I'm not sure if we'll actually see this occur in practice in what we're about to do. Probably not. But I can give you a simple example. Let's suppose you wanted to parse a number. And I just want to say, hey, let's take as much of the string as has numbers in it and turn that into a number, right? So what I might do there, if I was using a null terminator string, is just say, while the character is a digit, continue. Because I know that if I hit the end of the string, I will get a character that isn't a digit, the null character, right? So I don't have to also check for the end of the string, because checking to see if something's a digit also checks if it's the end of the string. That convenience goes away when you have length strings, because length strings do not have any special character at the end of them. They simply told you where the end was and they expect you to observe it, which means that every operation that you do of that form has to have an additional check. Sometimes that check is free because the way you would have been checking before would have been to check explicitly for the null terminator, in which case it costs you effectively nothing. But in other cases, you could have gotten the check for free because you were doing, let's say, a bounds check on a character to see whether or not it fell within a range already. That check will also check for the null terminator for you for free. So you've added one additional bit operation on there that has to get anded in. And that's kind of, that's kind of what I would point out there as a downside to this part of the process. So what I'm going to do here is I'm just going to say that there's a struct string. And what I might do is I may even go a little bit further and just call this, unify this actually with what we had. I think we've got one in here. Yeah. So we have this sort of concept in here of these stream chunks, right? What I might do is say that let's just call this actually, a buffer or something like this. Let's just make this fairly generic. and say that maybe we'll actually just make this 16 bytes long. So it's, a nice aligned little thing. And it can remember any size plus a region, right? And then inside here where we have this content size and contents, I could just make this like that, right? Something like this. So that's all I'm going to do. And so here we'll do this, like so. Let's keep going there. Oops. Oh, whoops. What is this stream file bit? So this is the same thing here. So this should just be one of these. And then this gets even better because then that just works, right? All right. So contents count. And that's all good. Contents count, contents data, contents dot data. This is just advancing this. So actually this is now just that, right? Like so. And what you can see there actually also that is if I start to do this, you can see some operations that actually already make sense. Right? So I can do a thing where I just say like, okay, I've got a buffer. I want to advance it by a certain amount. And what I can do here is actually just do something like this, where I say, if you want to advance a buffer by a certain amount, I can actually just make this be sort of the operation in question. So assume if, this buffer can support an advance by the count that we're talking about, then it does, right? Whereas if, if it can't, it can't. And I could also make that so that it, returns the result here in this fashion, right? So if you want the old pointer, you can have the old pointer back. If it returns 0, that means that you weren't able to. It will suck up that amount of data. Here we go. In the case where it can't do it, it'll just say that, it'll say that it hit the end. What I might do too is put it at the end. So that will basically just advance the pointer by exactly how much there actually was, right? Not sure if that's exactly the function I want, but it seems reasonable. So here we could just say like, oh yeah, refill if necessary file. Here's my results. My result is just advanced by whatever this count is, the file contents. And then if, the result comes back null, then I want to just, mark that down as a bad situation that we didn't want to have happen, right? And then off we go. Let's see here. I feel like, is Alan on today? Alan is probably not on today. I think he's on vacation. I have noticed that for some reason, I've been having 4Coder jump to the second error in the stream sometimes. I didn't know if that got fixed yet. I wanted to check. Like, it doesn't jump to this. It jumps to this for some reason sometimes. I'm not sure why. Because it didn't used to do that. I don't know why it does that. I do have to update this for Coder, so it may already be fixed. I should probably update this for Coder. I've been waiting till the next for-coder update because it's a pretty big one. It's got the lister API, so I'm probably going to do a pretty big update at that point. But I figured I'd check anyway. All right, so, but moving on. So let me just finish porting this here. So at content size, again, that's actually going to be contents count. Comp data dot count. Oops, contents count. 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 Here we go. Contents count. That'll probably error out because we can't actually, this won't support a 64-bit read. What's our safe truncate? I feel like that should really be safe truncate to U32, like so. So I'm going to rename it that. There we go. Buffer to, oh, no, that's not true. It was complaining about something else, I think. It does accept a size T there, so that's great. Even better. So those are 64-bit now? Oh, that's great. Good job, C runtime library. Contents.data, contents.count. All right. So now these are just safe truncate to U32, safe truncate to U32, and we're good to go. So I think that's all we need. I'm going to go ahead and run just to make sure that I didn't break anything with that change. I'm going to make sure that the PNG reader runs and doesn't, roll over and die or anything like that. So there we go. All good, I think. Let me just verify that it actually was all good. Delete those and make it rewrite them just to prove to ourselves that it's not busted. Yeah. I also should double check the output, make sure there's no errors. Yeah, it's all good. While I'm in there, I can fix the error that someone mentioned on the pre-stream in the PNG, the test PNG reader. It swaps, as you can see here, right? And so one of the problems is that if you swap twice, you get an upside down alpha, right? Because you've swapped once and then you swap again. We might as well put the alpha, allow the alpha to be right. Call this invert. We can trivially just not invert. So if I add that as a pixel up, invert, OX8. Then when we do this, I can say, oh yeah, first time, pixel up, invert, second time, don't, right? Now, these are upside down, or what, the alpha's upside down. If I run it now, hopefully the alpha will be right side up. And it is, right? So that's actually much nicer, right? So there you go. That's that change. So if I now have one of these little buffer doodads in there, you can see how that's kind of just a little bit nicer. And you can sort of see how it actually also opens up the door to having some other nice opportunities here, like things that operate on regional data. We can sort of create utility functions now that operate on those conveniently. that saves us some typing. So that's all nice and good. And what I'd like to do is come on in here to the asset system part that we were talking about. And I want to go ahead and parse out this name into pieces. So I'm going to have some different pieces here that go along with sort of the stuff that we know is in there at the moment. And what you can see is we've sort of got underscores separating different parts. What I'm going to do is just say, look, what we have is up to 3 of these underscore separated pieces. So I'm going to just call these like pieces here and say that there's 3 of them. And the first 3 underscore based pieces that we have, I'm going to separate out into those strings for us to use later as token values, because we're going to potentially want to have a sort of pseudo parser. It's not really a parser in the strict sense of the term because it only is doing very basic matching. But it is more or less a parser trying to guess what the artist was trying to tell us with the file name so that we know how to interpret the file that we get. At the very least, we need to know obstacles, item, hand, cover, character, and block need to be handled specially. What we do with the rest of the information is kind of a different story. So, you know, that's, yeah. We'll see what we want to do with that a little bit later. We also want to ignore anything called template. So blank template needs to be not processed because those are just there for our reference. They don't actually participate in the end, like in the final sort of finished product that we ship to people. So they shouldn't be extracted by this reader. They should be ignored completely. So when we scan through here, I'm going to want to gather those pieces. So let's go ahead and do that. I'm going to go ahead and have an anchor here. The anchor is going to start at the base name itself. And then what I'm going to do is say, all right, we've got this scan. I'm coming through here. I look at the hash value. I update that every time through the loop with the new character that I see, and I'm going to use this hash value later on outside. In the meantime, what I'm going to do here is I'm going to look to see if the scan value happens to be an underscore. If the scan value does happen to be an underscore, I'm going to take a look to see about a piece count. If the piece count is less than the array count of pieces, then I'm going to consider this a piece, and I'm going to retire it. So I want to do this in one of 2 cases. If there is an underscore, then I want to do it. But also if there's going to be a null, I want to do it. So if star scan equals that, or, and in the one way to write this perhaps a little bit nicer is if this value that I'm looking at right now, the reason for that is then I can look at this next value as well. So if the next value would have been a null terminator, then I want to end as well, right? In either case. So looking at these 2, we have to differentiate between them eventually, but for the moment we can do the same code path on either one. So pieces, piece count plus plus will get retired here. That's going to be the string that I'm writing. Do it like that. So this string needs to get a count, and it needs to get data. We know what the data is. The data is the anchor value, right? That's this right here. Similarly, as soon as we're done with this, the anchor value can be equal to scan plus 1 because that's where the next anchor would be, assuming that we continue. It's only really relevant in this case, but we can set it in either case and it's not a problem. So when we look at the piece count here and we say, what is the, what is the next one going to be? Well, the count is going to be everywhere from where we're at now back all the way to the anchor, right? So it's going to be scan minus anchor. However, in the case where we're actually looking at the null terminator here, it actually needs to be one further than that, right? Because the null terminator happened actually on the next one. So in the case where I'm not looking at an underscore, I need to advance my count to account for one more. So I need to basically say if this was an underscore, then I need one more character. Otherwise, everything's square. So off I go, that's all fine. That'll break it up into pieces. And then I also have the hash value at the end. So now I've got just like the chunks and the hash, and I'm ready to go. So assuming that I see this hash value here, and I'm ready to reload this, what I then need to do is I need to find out if I've already got one of these or not. So what I can do there is I can just say for, remember we made this asset source file thing here. So for each source file that might match the hash, and I can just, I might just, again, keep changing the names here to just say, okay, these are source files. It's not really about the fact that they're watched, they're just source files. So sorry, for each source file that the asset system is aware of off of this hash value, if that makes sense, then I'm just going to loop through and check them. Like so. So what I want to do here is match. If I find one that matches, and how would I do that? Well, I have here a base name, right? And that base name has to match the base name that I was given. So what I want to do is say if, strings are equal, if the base name that I have is going to match the base name that I got from the file system. If those two things are equal, then these are the same file. Now, there is one sort of bizarre feature that we might want to consider here. And it's difficult to say whether we want to or not. On a Linux-like machine, you would have files be treated the same if they have the exact same file name, but no other time. On a Windows-like machine, files are considered the same file name if the lowercase version of the file name matches the lowercase version of the other, like if they would be the same if converted to lowercase, right? So capitalization is not relevant to the matching in a Windows-based file name. It's kind of busted, that's just how it is. How do I want to deal with that? Well, I don't want the game to think about that because the game would then have to understand what platform it was running on to a greater extent than I feel is necessary. So what I'm going to claim instead, this is what I'm going to claim instead, is that what we will do is we will force the operating system layer to prepare that for us, basically. So down there on Win32 Handmade, when it's actually doing, so here we've got our situation with Win32 get all files of type begin and so on, right? We're coming through here. We get all these things, and then we do wildcard to multi-byte right here, and we produce the base name, and that's the thing that we pass back to the app, and blah, blah, blah. Well, right there, we are now in a perfect position to lowercase-ize this name, right? Now, I don't know if we have a lowercase, we don't. So we'll write one. But right here, that's one thing that we can do. So I'm going to go through and make each one of these lowercase. Now, the problem with this is that it's not quite right if you use Unicode. So I'm going to I don't know if wide. Let me check to make sure wide-char doesn't do that. I don't think it can. I don't think the OS can do that for us, unfortunately. It can't. Um, and none of this is useful. I just wanted to check to see if they had one. I'll skip it for now. So I'm not a language expert, so I have no idea. But if you convert something to UTF-8, it's safe to convert it to lowercase, and it will do an ASCII-based lowercase, because anything that was extended will have the high bit set, so you won't accidentally lowercase a value that shouldn't have been a lowercased, right? You won't corrupt the string. However, what I don't know is to what extent lowercasing needs to be Unicode aware. So if you actually wanted to produce the lowercase version of a Unicode string, that would have to include lowercasing for characters above the base 127 character set, right? And so we're not doing that, so we're not technically doing the full Unicode lowercase. I don't care because our artists are never going to produce anything like that, and it's not a particularly bad bug even if we did. It just means if they use two different cases, the files would maybe, I don't even know. Yeah, it's not a particularly bad bug either way, but it would create issues with our asset system until they went in and actually deleted one of the two files, right? Or restored the case to the correct case. So there is that. It's worth noting. So if you actually want a good Unicode lowercase, you can't assume that the characters are only ANSI, because you may have extended ones that are multi-byte long. That's just the nature of the beast, right? However, if you just want to do a basic one, it's actually pretty simple. All you have to do is say, if the character that you're talking about is greater than or equal to capital A, and it's less than or equal to capital Z, then you know that it's inside the range of characters, right? And this works because, fortunately, the people who designed ASCII had a clue. If you go look at what an ASCII table looks like, what you can see is that all of the, capital letters can occur contiguously, and all of the lowercase letters occur contiguously. So all we have to do once we look for a range check and see that it's in between these is we just have to apply the offset. So all we have to do is then say, okay, just add however much it takes to change a capital into a lowercase, right? So I want to change capital A into lowercase a. However much that distance is, just adding that will automatically lowercase it, because no matter where you are in the table, that same stride will get you to the right lowercase value, right? So you can see it even in the numbers. 41 maps to 61, 42 maps to 62 in hex, right? So you can see that you're just twiddling some bits at the high end, and you've changed it from uppercase to lowercase, right? And again, that's because the people who designed ASCII, they knew what they were doing. They made it nice and easy to use in that way. Okay. So this will lowercase those file names so we don't actually care. And then when we string match, we're fine with it, right? If we find that we actually have a match, we can stop, and we now know that this file is a file we were already aware of. on the way out, if we don't know about this file, so we didn't find a match, then what we need to do is actually create one of them, and we need to initialize it into a state where it appears to be completely not had any data in it, because we're going to want to then load the file and actually process it. So that turns out to be pretty easy, right? So anyway, if we push a struct here, where we have an asset source file, a new one, what we can do here, and this will clear it as well. What we can do here is then put a copy of the string on. I want to do just a push copy. Actually, I guess I can do a push and null terminate. What's my easiest thing to do here for copying this string? I know we had a couple different ones here. There it is. So I'm just going to do a push string here. It's a little inefficient because technically I should just save the scan value because then I know how long it is and I can just do it in one go, but I'm not going to because it's not really going to matter at all. So anyway, pushing in the source here, I'm just going to say, okay, there's my base name. I'm going to push this string on. And so I just need my memory arena here. Now we've got a bunch of stuff pointed to here. This is the non-restored memory. And then we've got, I guess, so when you reset the game, it's non-restored memory because we don't care. Yeah, so this is the non-restored memory arena, and that's where we actually want this because we don't want this tracked across like loop code editing because this is for assets, which don't participate in that stuff. So here we could just say, all right, give us a new one of these. Now it's there. We leave the file date at 0 because we now want them to not match. So by now we have to assert that we do have a match, and we now want to say, has it changed? So if the match file date is not equal to the current file date, then what we want to do is update this file and remember that fact, right? That's what we're trying to do here. So in addition to, and this is like a to-do, update the actual assets. That's the part that we now want to write. So the other thing that we have to do here is actually store it into the hash. So the source file hash at the hash value, right? That thing is going to chain on to the end, like so. And then the source file hash itself is going to point to this as our first one. But that's it, right? So it's pretty simple. That builds up the entire hash. So now we just know what we've got. And this now tracks everything, right? That's all we needed to basically have a change processor. Now, the more complicated part is to actually go through and process the individual assets that are part of the file, right? And we've got a couple different things that we're going to have to do there. And yeah, I want to kind of go through those more specifically. So I'm not sure exactly how I want to structure this. Suffice to say, this call right here is the call that actually needs to do the processing. So here we have a update, asset package from PNG. We're going to pass that file info. Actually, I probably won't quite do that. So what I'll probably do here is load the file and then call this with the file data. So what I'd probably do here is push a temporary on and then rescind that temporary, right? So I'm going to want to load in a block, trying to think of what I want there. But the long and short of it is I'm going to call this stuff. So when we actually go to load a file here, I want to call this load it in. So I have a platform file handle. So what I need to do here is I need to open it. Like so. And this should be platform, this is open file. So that will open the file. Then I would do a platform close file. Like so. And I would just issue one read here. Platform read data from file. And that would just pass the handle offset size dest. And we know that we're reading the entire thing, so it's really just the file info file size. And this destination here is going to be a buffer that is however big the file size was. So we just need a temporary, we need to push a temporary on, and then we can after we load it into that temporary storage, then we can just get rid of that, right? So this is our file buffer. That file buffer will then be passed here. And the other thing that I would mention is this gives us yet another place we can actually use this system. Like I said, having one of these comes in handy pretty frequently. So I can just say like, all right, got to get the memory from somewhere, but otherwise, once we figure out where we want to store that, that's all we have to do. Then we pass that file buffer to update asset package from ping, and what we want to send that is the match that we used, the asset system, obviously, and we're going to let that function take it from there. This update here tells us what the file date change was. I don't know whether we want to do that before or after. You know, do we want to do this before or after? I'm not sure. You know, I think I do want that on the same line just so it doesn't get separated. So I'm not 100% sure what I want to do there, but something like that. And then once the package is updated, I also kind of want to record the fact that it's dirty. Because I think what we're probably going to want to do here is have a like made changes thing. And in here, I guess I would say this thing maybe returns whether it made changes. And in the case that we made changes, we probably need there to then update like some kind of asset information file that we have. And what that asset information file is going to be is just something that sits there telling us what the source files are, what their dates were, so that when that information about what assets went with them, so that when we close the game and reload the game back in, it will know that information, right? And I think that's it. Yeah. So I think that's everything that we need there. In our shared directory, so it's not a string, it's a buffer. Like so. And you know what I could do? I can also make it so that buffer and string are the same thing. Like we can do this as well. Because sometimes I like to be able to say string, because it's just a note to myself what's going on, even though those two things are exactly the same. Anyway. So... Excuse me. I think that's just about everything. So I think the only problem is now getting that actual data out. Let me make sure that's true. All right. So then we just have the actual update happen here. Oops. That needs to take the assets. It needs to take the source file. Oops, source asset, source file, and the contents. Then when we look at the PNG reader here, when that takes the parses PNG bit here, like so, that's going to take one of these file streams. And again, that's something that we can pretty easily, that's something that we can generate trivially from one of these little buffers. So we should be good to go. So I think that's just about everything we need for the change management. And so the one thing we don't know is how we want to deal with that temp memory there. So we have, obviously, in the game proper, we have the notion here. Oops. It's not the file I wanted. There we go. Inside the game state, we have various arenas that store stuff, and so I'm not sure what we want to do for the temporary memory here. I kind of feel like we probably just want to allocate it and deallocate it directly from the platform, because there's no reason not to. It's development only. So I feel like we almost want to just do that by just doing a platform allocate memory. And then a platform deallocate memory. And that should be fine. So there's a memory block. That's our temp block. Allocate memory takes the size and the flags. We don't care about that. So the size is just that. And that's it. So I think that's all we need. Pretty sure anyway. And I think that just does everything we want. So the next step is to go in here, right, into update asset package from PNG and loop through all of those tiles. So this is going to be like a for loop, right? It's going to first call handmade PNG, in here. You know what? Now that I think about it, we actually can do this. This is not necessary. Now I think about it, this is not necessary at all. We can actually just have this be a temporary arena, right? So basically everything that it does in here can just be done like this. right? Because that'll just automatically do it. And then when we come up here and we need to push a memory arena in here, we can also just say, we can say what the memory arena is that gets used for everything, for all the temporary processing. And that gets nicely cleaned up. Everything works just fine. It's trivial, no code. Everyone's happy. So really what we need is just the file stream here, the info bits here is for the error. But I'm not going to do that right now. That'll be tomorrow's job. But that's how that's going to work, right? And so we would just pass that temp arena in, and then I think we're good to go. So I think that's the whole superstructure for it. Right now, that pretty much does everything we want. In here, we'll have the for I loop that will loop over each of the tiles. We'll look to see if there's any data in that tile. If there is any data in the tile, we will record it as a new asset if the data doesn't match the asset that's in there currently. I think that's it. All right, let's Q&A. Thoughts on the use of persistent memory, e.g. Intel Optane, in game programming? So I guess what I would say is I don't have a lot of thoughts on it because it's not really different from what you already have to deal with. So it should slot into your system pretty routinely. Without a lot of effort. The reason I say that is because game developers are already used to nonsense like there's a server and the server sends, data to the client where it has to write it to a hard drive cache, where it has to move it into memory, where it has to move it into texture memory, right? And you're used to all of these like different levels of locality. It's just something that game developers have to live with, that other developers often don't think about. But game developers have to constantly think about making sure things are in the right place at the right time. So if you want to slot another thing in there that's like a different level of cache along the way, it usually doesn't really change the design of your system a whole heck of a lot. It's just adding some other cache that has a little bit faster speed and a little bit smaller size, right? Martins, are you sure always lowering file name to lowercase is a good solution? Because case sensitivity is a feature of the file system, not the whole OS. On NTFS, you can enable case sensitivity individually per folder. You can mount NTFS disk on Linux Mac, and on Apple HFS Plus or AFPS can be both. Case sensitive or case insensitive depends on how you format it. Like I said, I'm not sure. I'm also just not sure there is a good solution. I don't know what the right solution is for this case because the file name actually means something. So you're just not really allowed to save two files that have the same file name and just differ in case and expect the game to care about that, right? One is going to have to overwrite the other. So I think what I want is to just always flatten it down. I think I may want it to flatten always, period. Meaning the OS layer, even on a case where it does differentiate by case, still shouldn't, because we can only pick one, if that makes sense. Long Boolean. I can't remember. Are the bitmap assets stored next to the audio and font glyph assets in memory? This may be relevant if those are not the same size as the bitmaps. It's not really relevant, no. The reason for that is if a bitmap is always replacing another bitmap, you don't care where it is, you just care that the size was that big, right? So all we really care about is that the hot loadable assets slot into a particular size type, because that allows us to overwrite the old version without having to do a lot of memory, without having to do analysis of a free store, which is not the end of the world anyway. Like, we could just do that. It's a waste of time if you don't actually need it. And a lot of times you don't, because you need to end up with unit size, like things that are a particular size for the texture for the texture memory on the graphics card anyway. So a lot of times it's not really up to you, if that makes sense. What's the mnemonic device used in UMM? I get that it's a size T, but what does UMM stand for? Quite a few people on the stream ask. So the reason for that is that the convention that I had for using signed and unsigned was the first thing tells you whether it's signed or unsigned, so S or U. And then the number tells you how many bits it is, 32 bits, 64 bits, 16 bits, 8 bits. The problem then becomes when you get something that you just want to say, I need this to be the same size as some logical thing. So in the case of UMM, it's like I need to say that it's the size that a pointer is. And so I just picked memory model. Like, it's the size of whatever the memory model needs it to be. So it's just UMM. And that's it. I don't have a strong opinion about that. UPTR would be another reasonable one. UST, if you wanted to be like use size T. UPP for, pointer. Anything is fine as long as you remember it. Yeah, pick whatever you want. Just as long as you remember it. Thoughts on use of Vulkan for a 2.5D game like this? Is it overkill or is there a benefit? Again, I don't think Vulkan is particularly useful. It kind of is an API I don't see the point of anymore. But I'll answer the more general question. Should you write like a metal version of the game on Mac and a D312 or 11 version on the PC? Yes, it's valuable. Like with D3D12, you could definitely do some things with how you overlap the texture downloads and things like that. You could definitely do useful things with it. So it's not overkill. On the other hand, is it strictly necessary? Probably not. Because, well, I think it is. So for example, say you want to keep pushing on the lighting quality, which we might want to do later on, right? Maybe we want two modes of the game in the final version, one that's, can be run on low-end systems and the lighting's kind of crappy, and one that runs on high-end systems only, like, GeForce Titan or something, right? But that has really cool lighting and doing all this ray tracing and stuff on the graphics card or something, right? Those things are typically good to program in like a D3D12 or whatever, right? That would be my guess. And on the Vulkan front, the reason I say it's not useful anymore is because Apple made it clear that Metal's the only game in town. So for Mac OS X and iOS, you're going to be programming Metal full stop. Nobody cares about Android unless you ship free-to-play nonsense games, which we don't, right? They don't have a market for paid games on Android, pretty much, period. So Handmade Hero is not an issue on Android. Neither is anything anyone would ship probably as a game. You have to be shipping like free-to-play nonsense if you want to be on Android. So assuming you're charging money for your game, you're talking about iOS, you have to use Metal. Same with Mac OS X. That's the only game in town now. They have officially said that OpenGL is gone, right? So if you're programming Metal on that, it only leaves one other platform for you, besides consoles, which are all custom. And the other platform you have is Windows, and Windows is D3D. There's no point in Vulkan, right? It literally doesn't give you anything. You can't use it for cross-platform because it's going to be it's going to be a cruft layer on top of anything you use on an Apple platform. So you might as well just use the actual thing that the operating system supports and get rid of the Vulkan layer, which is just cruft, right? It's no longer the direct layer. It's Vulkan is basically OpenGL now. It's a thing that sits on top of the actual graphic system, and probably will, not be nearly as well maintained as the official thing that the operating system itself is running through. So as far as I'm concerned, you can forget Vulkan. I mean, Vulkan's a non-issue. Maybe on Linux and Android it matters, but it's completely irrelevant, I think, for the future of games at this point. Unless there's some major change in the future, and one of the platform holders adopts it. But assuming that neither Apple nor Microsoft adopt Vulkan, it's dead. I mean, it's a non-issue. It literally won't matter to anybody. People might use it as a compatibility layer the same way they were using OpenGL, but if you're looking for something that's a smart way to partition your game's rendering system, it's going to be Metal D3D. End of story, right? And I really don't see any arguments the other way. Vulkan's certainly not a good API, so you're not getting anything there either. It's a lousy API, so you're not getting like any kind of good like ease of use or like well thought out clean bonus from it. It's a giant tangled mess. Oh yes, someone just pointed out a typo. But that is what I did. Sorry, I'm not sure what you're talking about. I think you meant to add to string count when scan 0 is not equal to... Oh, yes, sorry. Yes, that was the typo. All right, looks like that's like the end of the questions. I've been listening to early episodes of the Jeff and Casey podcast and wanted to ask you if you feel guilty for giving EA all the advice, which they definitely follow. I feel like I'm absolved because I feel like they would have come up with it themselves. There are some very smart people there. Those people are not necessarily putting their smarts to ethical use per se, but they're smart. I think they would have come up with it themselves. I think they would have. I don't think they needed to take advice from me. So I wash my hands clean of that. Enthusiast, thanks a lot for all these great educational materials. You're very welcome. Thank you for saying so. Could you explain why OpenGL is a state machine? I guess I'm not sure what you mean by that question. Can you be a little bit more specific about that? Do you have a particular piece of documentation to which you're referring? Brian, why is scan 1 equals 0 and not scan... Oh, so in this case, so what this is doing here, and I probably should have explained this a little bit more carefully. I just kind of wrote it out in a hurry. What I want to do is I want to separate something out into chunks based on where the underscores are. So if I see an underscore, I want to record a chunk. But the last character in the file name will not be an underscore, probably. It will just be a regular character. And so I want to also record that as a chunk, or a piece, I should say. So what I want to do is look to see, am I on an underscore? If I am, then I've hit the end of a chunk. Or is the next one a 0? And if so, then I've hit the chunk. Hit the end of a chunk as well, right? So there's two ways to write this. I could write it looking at the current one to see if it's a 0. But then I would need an if in here that does if star scan break right here. Or I can use a for loop that checks it here and then do the plus plus string count thing. It's 6 of one, half dozen of the other. I don't know that there's a strong opinion about it. I'm happy to write it the other way as well. So like just to show what the other way would be, what I mean by that is I could take scan and move it outside, right? And then I would say that this is just a for I loop that looks like that. Every time through here, I do a plus plus scan like so. And then here I do a thing that says, if scan 0 equals 0, break. And then this thing does like, if, scan 0 equals 0, then I'm also at the end. And we always do the count like that, right? I don't know that there's necessarily like a clear reason to prefer one over the other. Yeah, I don't know. Furthermore, you could still put the while down here if you wanted. Get rid of this and actually just count it. But anyway, that's the other way to write it. If you like that one better, by all means, write it that way. I don't know that there's a clear reason to write it one way or the other. So. Is the answer still no to doing my comp sci homework for me? Yes, it is. I'm not going to do your comp sci homework for you. You have to do it yourself. You're not going to learn anything if you don't do it yourself. Brian, okay, sorry I missed the scan check first, which of course would mean scan 0 would never happen. Yes, exactly. A bit off topic, but there are intrinsics for bit interleaving I can't find on the Intel intrinsic webpage. I was thinking they might not have named it interleave or some such. Can you be more specific about bit interleaving? Do you mean literally taking every other bit? So like take one bit from one value, one bit from another value, one bit from one value, like that? Like each individual bit? Is that what you're asking? Once the game is completed, and I know that will take a long while, are there any plans to do similar educational series? No. Should those pieces also be passed to update asset package from PNG? As far as I can tell, you're parsing them out but not using them. Yeah, I don't think so. So I think what's probably going to happen, not to, spoiler warning, update asset package from PNG is probably going to take something. We could pass it. Don't get me wrong. Maybe we will. But probably what I'll do is have a parsing function I call here that produces a 8x8 that says what all of the tags should be based on these names. And then that is probably what I'll pass to update asset package from ping. Probably. Don't quote me on that. But that's probably what will happen. They will get used though. I don't have anything yet for it. VTL element, yes, every other bit. Mm. Every other bit, huh? So I'll be honest, nothing comes to mind, but for pretty much almost the entirety of my SIMD programming, I've always been confined to SSE2. And I don't remember there being one in SSE2, but it may just be that I never needed to use that. I can't think offhand of any time I would have had to use that. So I think I probably wouldn't remember it. I probably would have seen it if it was there, but I probably wouldn't remember it was there. So I'm assuming. So which? I don't know which you're talking about here, but let's say you're talking about modern chips. So we're looking at these. Um, and you know, you want to see if what the unpack, uh, what the unpack stuff is. So obviously you can interleave byte at a time. That's what the unpack low EPI8 would do. But yeah, not looking great. Trying to think. Wait, what? Did that really suggest that there's no bit manipulation in any of these other ones? All right. That seems a bit weird because mask move is a bit manipulation in a sense, right? Yeah, I don't know. So I'm thinking that insert is probably the only thing I've never looked at that could do something like that, and I don't think it does. So all I can say is I don't remember one, but there's definitely some of these that I never looked at because they weren't available at the time, and there might be something in here that can help you. So I would just keep that in mind. Um, Insert still only works on bytes at a time. Yeah, I don't know. Sorry, I really don't know. Uh, Blend also is only bytes at a time, if I remember correctly. Pretty sure gathers are only bytes at a time too. I don't know. So the one thing I could think of was the mask moves, uh, and it's not that. It's not mask move. It's move mask. It's the opposite. It moved these. The one thing I could think of was these, and they don't really do what you want, but they're at least something that actually takes bits. Um, Unfortunately, it's going out to the general purpose registers. If I remember correctly, so it's designed for branching and stuff like that. So it probably really just doesn't help you, but it does do that interleave. So let's say you've got, 16 bytes in a register. You issue a move mask, you get the top bit of each. You can then shift it one over, do it again, and get the top bit of each, right? So that does do a bit interleave, but I don't know the speed of it, and it's not internal to the, like, you want something internal to the XMM registers, and this goes from XMM to general purpose, which is probably not what you want at all. So I'm sorry, I'm having trouble thinking of anything that's gonna help. Sorry. It could be that once you get up to AVX 512, it's in the mix. Sorry, I can't think of anything. Brian, I seem to have missed a lot of the memory arena work, but you create a temporary memory arena. Where do you pass in the original memory that you've allocated? Normally, I would think global variable, but if in the game layer, that would get reset when you reloaded. So currently, the way it works is it just, if you don't provide any memory, it just asks the platform layer for it. And that's it. Jeff Phoenix, I don't know if this has been asked for, but would you consider having your VODs do reruns on days you aren't going to stream? Just so people can still participate in the chat, you mean? Like, why wouldn't they just go to the episode guide and watch them whenever they want? Like what would be the point of the rerun? Is it just to have the chat? Or... On my day-to-day, I find myself using standard string very often. Should I write my own string library, or what other options would you recommend? If so, how do I handle allocations? A single huge allocation doesn't seem to be the right choice since I'm not writing a game. Allocations are obviously something that's kind of a broader topic, so it's kind of hard for me to discuss without knowing what you're doing. But standard string is a piece of garbage, and you should never use it for anything. It's just terrible. So yeah, definitely don't use standard string. I would highly recommend writing your own string library. Even if that string library just does raw allocations anyway, it's still going to be better than standard string, because standard string is absolutely horrific. It does everything wrong that you can do wrong. Don't ever touch it. It's awful. Just absolutely terrible. I would use something very much like the buffer struct that I just wrote out there, and write a little library that works with those. And how you want to do your memory allocation is kind of a broader topic that isn't really restricted to string libraries. What I would point out is that once you have a count string where you say, here's the number of characters and here's a string, you find that you really don't have to allocate memory all that often. When you concatenate two strings together, you do, but that's about it. For absolutely everything else, you can just use subregions, and it works pretty well. So you'll find your allocation count goes down dramatically when you stop using null terminated strings, which helps make the memory less of an issue, because even if you just use a general purpose allocator and allocate every time, you're still probably going to be fine. On the topic of VODs, I was curious why you don't have your broadcast saved on Twitch. Say someone misses something you said, wrote, and wants to go back and listen and watch quickly. There's no way to do that until the VOD is uploaded on YouTube. Because the pre-streams are supposed to be just for people who watch. If you want to hear the pre-stream, you got to show up. In a semi-related thought to GG Nate, have you ever considered using a program that overlays the Twitch chat into OBS? I see entertainment-focused streamers using them, and it's really nice for when they reference something from chat and you're watching the YouTube upload stream. No, I don't like that because that allows other people to basically post into the video, which I don't allow. Months ago, when you were playing Intrinsics, you added one that used SA 4.2 instruction. This isn't supported by most older AMD chips like mine. Would you consider a workaround for this? Possibly, but no guarantees. Let's take a look here. Oop, looks like we need to update Google Chrome. Maybe I'll do that later. All right, thanks everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org. And it comes with the source code so you can play around with it. We also now have some random new website stuff that you can go to, which is kind of fun. We've got the Handmade Fund, which is a thing that supports community projects. I would highly recommend checking that out. And you get a little bonus pack that's fun with a bunch of different source code things from old projects of mine. That's definitely something to check out. We also have a watch page now that has the live stream on it when it's streaming. And also it has the episode guide integrated into it. So it's like kind of a nice place you can go to watch stuff. And yeah, it all works pretty well. It also has the schedule posted on here. So as soon as I go off the air, this stream is replaced with something that tells you when I'm going to be on the air again, which is pretty handy. So yeah, highly recommend checking that out as well. And it has hot links on it for other things like pre-ordering the game or signing up for the mailing list or going to the forums, that sort of stuff. So definitely check out the new website. And also you can check out any of our Molly Rocket websites just by clicking on the little icon at the top. And that goes to all of our pages for quick links as well. So anything that you might want to do, we've got up there now for you because we moved the Handmade Hero website over to our general website stuff that handles all the stuff on Molly Rocket. So it's a lot more functional and interesting now than it used to be. So check that out. I'll be back here tomorrow to do some more on the asset loading. We've got our self in position to actually process the PNG data now and put it into the asset file. So that's what we want to do next time. That should be pretty straightforward, but then I think when we get to the tags part, that's when we're going to have to start really putting on our thinking caps. So tomorrow should probably be pretty straightforward, but next weekend that might be a little bit saucier. So definitely you'll be able to have a couple days of rest before we head into that next week. But tomorrow should be pretty straightforward. We already wrote the PNG reader, so we're just doing something that scans those blocks and looks at when it actually needs to update stuff. Shouldn't be too hard. Hope to see you back here for that. Till then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.